In this tutorial, we will be discussing complete and net ionic chemical equations. Alright, so let's take a review of how to predict the products to begin with. The key to predicting precipitation is that only the insoluble compounds form the precipitates, and they come out as solids. In the precipitation reaction, two solutions containing soluble compounds combine and an insoluble compound precipitates. So initially, we have two beakers here. Both have ions that have been dissolved in water. That's why you see AQ here. AQ means aqueous, which means it's been dissolved in water. This plus sign here means that we're going to add these two things together into one bigger beaker. So now all four of those ions exist. Notice with lead iodide, it went from AQ to S. That means that it's insoluble. So when we go over here, what's happening is the inside ions are coming together and the outside ions are coming together. So the potassium is now with nitrate, which is written right here. And the iodine is now with lead. Notice the lead's written first because the positive is always written first, which is right here. Notice another thing, that there's no number down here next to the iodine on the left hand side, yet there is here on the right hand side on the products. That's because lead is a +2. Don't forget that these subscripts, unless it's a polyatomic ion like NO3, these subscripts come from the charges when you crisscross. Alright, so then we can see in the beaker that lead iodide formed as a solid, which is written right there. And so therefore it precipitates out. It falls out of the solution. So as we're writing these, the outside ions come together and the inside ions come together. Because this is a plus minus arrangement, the plus and minus of the opposite compounds are the ones coming together. So we have NaCl as a possibility, and we have CuCO3 as a possibility. Once you have the letters, make sure you double check it with your charges. Na, if you look on the periodic table, is a +1. Cl, if you look on the periodic table, is a -1. Crisscross it and you have 1 and 1. CO3 is a polyatomic ion with a -2 charge. Cu is a transition metal, so we have to figure out what that charge is. This 2 from the Cl originally came from this copper charge. So that means this copper over here is going to be a +2 charge. If you crisscross this down, the 2 and the 2 cancel out. So from here, we got to figure out whether these are going to form a solid or an aqueous solution. NaCl. Cl is right here. It says it's mostly soluble unless it's paired with silver, mercury, or lead. Well, here it's paired with sodium, so this is going to be AQ. Copper 2 carbonate. Carbonate's right there. It says mostly insoluble, so it's going to form a solid unless it's paired with lithium, sodium, potassium, or ammonium. Well, copper is none of those, so that means that's going to be our solid. That's going to be our precipitate. So notice that we add these letters here to say solid and aqueous. If they both turn out to be AQ, if they're both soluble, you're going to write no reaction instead. From here, we balance the equation. 2 sodiums on the left. There's only 1 on the right, so I'm going to multiply sodium chloride by 2. 1 carbonate on the left, 1 on the right. 1 copper on the left, 1 on the right. 2 chlorines, 2 times 1, because I put that 2 as a coefficient in there already. Alright, so let's practice this. The inside ions come together. The outside ions come together. So, we have Ag and Cl. Now, Ag is typically a transition metal. However, it's one of the few transition metals that don't change. So, it's going to be a +1. Cl is a -1. Crisscross it for 1 and 1. The inside ions come together, H and NO3. H is a plus, NO3 is a minus, crisscross it, and it becomes HNO3. Now that we've gotten this far, we had to look at our solubility chart. So we see chlorine here is soluble, except when it's mixed with silver, mercury, and lead. Well, that's what it's mixed with right here, so that's going to be an exception, and it's going to be our solid. HNO3 nitrate is right here. It's soluble with no exceptions, so that means that's going to be AQ. Alright, so now we're going to move on to something called a molecular equation versus an ionic net, a complete ionic, and a net ionic. There's differences between these three types of equations. For the molecular equation, that's what we've been doing all this time. It's just simply writing out the compounds and putting A, Q, S, L, and G next to it to signify how many we have of each. Now we're going to talk about complete ionic. What happens with complete ionic is every time you see AQ, you're going to break it into the ions that it makes up. So AgNO3 goes to Ag plus, and that's AQ, it's dissolved in water, and NO3 minus, once again, dissolved in water. I see AQ for NaCl, so I have Na dissolved in water, and Cl dissolved in water. Don't forget your charges because these are ions. That got broken up into Na and Cl. I see solid here, so that doesn't break up. So I'm going to keep that as AgCl. I see AQ here. I'm running out of room, so I'm going to go to the next. I'm going to go down instead. Na plus dissolved in water, and NO3 minus dissolved in water. So all I've done here is taken anything that says AQ and broken it up into the ions. Make sure you put AQ next to it, and make sure that you put the charges down. Alright, so now let's take a look at things that are both the same on the left and on the right. So notice Ag is inside the solid here. That actually did something. The Ag actually participated in the chemical reaction. Whereas the NO3, it looks the same on the left and the right. When that happened, same with the sodium, those are called spectator ions. They don't really do anything that involved in the reaction itself. They sat back and they watched the reaction occur. That's why they're called spectator. So in the net ionic equation, we take those ions out. So we have Ag, which is part of the solid, and we have Cl that's part of the solid. And that is what our net ionic equation is. So molecular equation is the chemical equation showing the complete and neutral formulas. So having everything combined. The initial compounds. The complete ionic equation is where you've split up anything that's aqueous into its separate ions. And the net ionic equation is when you're removing the spectator ions and you only focus on the ions that actually participate in the reaction itself. Alright, so let's do a couple of practice problems of these. So we're given two ionic compounds in two different beakers and we're mixing them together. When we mix them together, we're going to take the inside ions and put them together, and we're going to put the outside ions together. So the outside is Li and Cl. Li is plus 1, Cl is minus 1. We're going to crisscross it to be 1 and 1. And we have Ca with SO4. SO4 is a polyatomic ion, so it's going to stay put even though it has a subscript. That 4 is going to stay with it. Ca is a plus 2, and sulfate is a minus 2. We're going to crisscross it, and it's going to cancel out to be 1 and 1. From here, let's go ahead and balance the equation just to make sure everything's balanced. We have two lithiums. We only have one on the right-hand side, so we're going to multiply LiCl by 2. SO4, we have one SO4 on the left. We only have one on the right. Calcium, we have one on the left. We have one on the right. And chlorine, we have two on the left. But because of this 2 in front of LiCl, we now have 2 on the right. Now let's look at the letters. The solids, aqueous, gas, or solid, liquid, gas, or aqueous. Alright, so LiCl, here's chlorine. It's soluble except for when it's with silver, mercury, or lead. While here we're with lithium, and so this is going to be aqueous because it's soluble. Calcium sulfate. Sulfate's right here. It's mostly soluble except when it pairs with strontium, barium, lead, or calcium. Here it's with calcium. So we're going to put with an S with it. Alright, so let's do the complete and net ionic equation now. Anything that says AQ, we're going to break up into its ions. So I have Li plus. I have two of them, so I'm going to put a 2 in front, and that's aqueous. I have SO4 2 minus. Once again, that's aqueous. I only have one of those. I see aqueous again, so I'm going to break those up. Ca2 plus, aqueous, and Cl minus, aqueous. Notice this 2 here, that means I'm going to put a 2 in front. That's supposed to be a C. Yields. I have aqueous here. I have a 2 in front, so I'm going to put 2 Li plus AQ. And that 2 goes to the chlorine as well. And I'm running out of room, so I'm going to put it on the next one. I see that says solid, so I'm going to keep that as a solid. CaSO4. Alright, now let's look for the spectator ions. The spectator ions are anything you see exactly identical on the left and on the right. So here I have 2 Li and 2 Li. Those are a spectator ion, so I'm not going to worry about that. Here, for chlorine, I have 2 Cl minus and 2 Cl minus. That's also a spectator ion. So, this one, the top one is the molecular formula, molecular equation. The next one is the complete ionic equation. Now the net ionic equation is combining the ions that actually participate in the reaction itself. And that's the net ionic equation. It takes a little bit longer, but it's not difficult. You just have to have confidence that you know what you're doing. Alright, so let's do one more example. Ag and NO3 react with KCl. So Ag now gets put with Cl. Ag is a +1, Cl is a -1, crisscross, and it becomes 1 and 1. And now K combines with NO3. K is a +1, NO3 is a -1, crisscross it, and it's 1 and 1. Now let's take a look at our solubility rules. Chlorine is here. It's mostly soluble unless it's paired with silver, mercury, or lead. Well, since it's paired with silver here, that means that's going to be insoluble, which means it's going to be a solid. Potassium is here. It has no exceptions. It's going to be aqueous no matter what. I could have also looked at the NO3, which also is soluble. Alright, so here, my PowerPoint got a little messed up, but that's okay. That should be over here. We're going to break up to get the complete ionic, we're going to break up anything that says AQ into its ions. So Ag plus and NO3 minus. I see AQ again, K plus and Cl minus. Yields. This says solid, so I'm going to keep that together. And I see AQ here again, so K plus and NO3 minus. Alright, so there's my complete ionic equation. Now I'm going to take out all the spectator ions. So I'm going to take out anything that I see on both the left and the right side. So NO3 gets removed, and the potassium gets removed. That leaves me with Ag plus with the aqueous, Cl minus with an aqueous, to AgCl solid. And that's how you do complete and net ionic equations.